Today we would be solving a easy problem from leetcode, that is 2sum problem. In this problem you would be given an array of integer nums. For example, this is the array. You would be given an target, that is 9. So what we have to find out, we have to find out the pairs whose sum would be equal to the target. So instead of returning pair, we are asked to return the indexes. So for example, in this given input, 2 and 7 are going to form a sum as 9, and we are returning their indexes 0 and 1. So when we are asked this question, as this is a easy question, we are expected to give an optimal solution. So brute force can be, we can use two loops. One starts from 0 to n, another one starts from 1 to n, and you would be comparing these two states. When these two elements, sum of these two elements become 9, that is target, then we would be returning these two indexes. But the complexity of that problem would be high, so we need to find a optimal solution. So one of the approaches, I'll write down the approach how we can do it. Let's say you have this array 2 7 11 15. Now you have to find out the pair whose sum is equals to 9. Okay, so when you start visiting this array will form a memory map. So when I say a memory map, it is nothing but a lookup which we will create, and we can refer it going on. So I'll go with an example. So let's say we start looping through this array. The very first element is 2. Okay, so in our lookup we would be putting this value. So we will have a lookup table, let's say a map will have a key value pair. Key would be the number and value would be the index at which point we have seen it. So instead of saving the number, we would be saving the negation of it. The reasoning behind saving the negation of that number is, so let's say you are at 0th position, so you are saving 9 minus 2 here, that is 7 comma 0. When you move to first position, you will actually do a lookup in this map, and you will check whether you have seen this number before or not. If you have seen that number before, that means you already found a pair whose sum is equal to the target, like this. So we'll try to implement it by this way. I'll take a map of integer, say it as memory hash map. Now I will start looping through my array. Loop th. Now we'll write the base condition. What if we don't find any pair? So we'll return simply a int array where we can give some indexes, let's say -1 comma -1. That means we haven't found any valid combination, valid indexes. Now what we will do, we will check in this map if this map consists of tens key So this is the same condition. So let's say you started with input 2. So at the very initial step, 2 won't be present in the map, so we will put it along with the indexes. Memory dot put, we will put target, that is your sum minus the current value of it, nums of I. So by this, along with the indexes, so by this the very first initial value in map would be a 7 comma 2. This is the first entry set which which would be created in the map. Now on the second loop we'll get an element 7. We'll check if map contain this element or not. So if you see, this element is already present. So here what you have to do, we have to just return the pair because we already found it. So what we have to return, we have to return its index, as it is given in question that we have to return the indexes. So what this line means is, if it contains the key, that means it contains target minus nums of I. So one part would be nums of I and another would be target minus nums of I. So it means for both of them sum is same. So we will get the index that is already saved, that would be memory dot get. We are trying to get this index, nums of I. Okay, let's try to run this code. Okay, I forgot to place I plus plus. Okay, it is my bad. It should be outside your loop. Okay, so answer got accepted. Now let's submit the solution. Yeah, so if you see, its runtime is 0 millisecond and it took some memory. And if you see the status, you can actually check. So our solution, we are at here, and we can talk about memory distribution in other videos. Thank you.